Hi, Rex. I'm just noticing, I think you just forgot a comma there. And then it doesn't look like WebAssign is liking how you're writing this, that plus minus. So instead you can do just I minus 9j, or here as they're showing it with just the components. And then here it's that plus minus, so either 3i plus 36j or just 3 comma 36. And then just be careful that you go into the vector section, which I think you're doing. Oh, actually here, I think you may have just used a J on your keyboard, but you got to go in to functions and then vectors and get that correct J, and also these those brackets. Okay, let's see what happened here. This should have been positive, so let's see what happened. Usually I just rewrite these. Let's see, U is I plus J, so it's just each component is a 1. V is positive 1, negative 1. Okay, so here if we're taking negative 3 times V, you're basically just distributing that negative 3, oops, that's a negative, times 1, negative 1. So then you would get negative 3 times 1 would be negative 3, and the horizontal component, and the negative 3 times negative 1 is positive 3. So that's how we get this one. Let's see what happened here. Let's see, 3u minus 2v. Okay, so we'd have 3 times u, which is 1, 1, minus 2 times v, which was 1, negative 1. So I'll deal with those. So it'd be distributing that 3, I'd get 3, 3. Distributing the negative 1, we would get negative 2 and positive 2. And then we'll just add those x's. 3 plus negative 2, 3 plus positive 2, and so then that would give us 1 and 5. You just forgot the 5 there. Okay, now with vectors, when you see this, we're used to that being absolute value. And so it's just different notation. It's frustrating because it's the same, it looks the same. Some books do it with a double, those vertical lines, which I kind of like, because then it's clearly not absolute value. Okay, so this is magnitude, and the way that we deal with magnitude is we take the square root of the, let's see, it'd be a squared plus b squared, where a is the difference between the two horizontal components, and b is the difference between the two vertical components. Okay, so if we have some vector, right, where v is a and b. Okay, so let's see. In this one, u is given as 2i plus j. Okay, so I like to just write that with my components. The horizontal component is 1, and the vertical component, or 2, and the vertical component is 1. So the absolute value of that, if I was going to sketch that, I would have horizontal is 2, vertical is 1. So it would be going in this direction, and then I can find that length by just using the Pythagorean theorem, which is what this is. Okay, so we would just do this length right here, which is the magnitude of the vector. That would be equal to the square root of 2 squared plus 1 squared from Pythagorean theorem. Okay, so that's where that's coming from. So it would be the square root of the x component squared plus the y component squared. So that would be the square root of 5. Okay, that's A. And then B, we're supposed to find the magnitude of V, and it's just the same, except V is given as, let's see, 3I minus 5J. Okay, so then we would take the square root of the horizontal component plus the square root, or sorry, the vertical component squared. I said square root. So what do we have? 9 plus 25. So that would be the square root of 34. All right, and I'll just do one more. We have also the magnitude of 1/2 of V. Okay, so first we want to figure out, well, what's 1/2 of V? And V we just found was 3, -5. This is 1/2 V. So this would be 1.5, or just 3/2, and -5/2. Okay, so then if we're doing the magnitude of that, then we take the square root of the horizontal squared, that's a 2, plus the vertical squared. So that would give us 9/4 plus 25/4. So what is that? 30 square root of 34/4, square root of 4 is 2. I think the way the book does it is they take that as 34/2 and then just simplify that to 7, or that over 4, 17/2. So they would accept either of these answers, where that square root includes the 17/2, or that is also correct, where you've taken the square root of the 4 in that denominator. Okay, so hopefully that's kind of making sense. That's how 12 and 13 are. All right, now you had asked about finding the horizontal and vertical components. So if I'm given this, which is the magnitude of the vector, so if I can kind of draw this, 30 degrees would be about here, and let's say that that has a length of 26. So that's the magnitude, and this has an angle of 30 degrees. Well, we can use right triangle trig because we want to know the vertical and the horizontal. Well, this length right here, if this is x, this is y, we would have the sine of 30 degrees is equal to the opposite over the radius, and so that's a y. Okay, so y, the vertical component, if we multiplied both sides by 26, would be 26 times sine of 30 degrees. Okay, likewise, the cosine of 30 degrees, that would be the adjacent, which is x, over the hypotenuse, which is 26. So the horizontal component would be 26 times cosine of 30 degrees. And we can generalize this where we have the horizontal component would be the magnitude times the cosine of the angle, and the vertical component would be the magnitude times the sine of the angle. All right, so just sort of generalizing, or that was the generalization, but if we're going to go back and finish our problem, let's see, y is sine of 30 degrees, that is a half, so it would be 26 times a half. So y is 13, and the cosine is square root of 3/2, so that would be 13 times square root of 3. Okay, and then we're just going to put those together so that our vector, we can write that as the horizontal component and the vertical, or we could write that as 13 square root of 3 times I plus 13j. Both of those are correct, and it says write the vector in terms of I and j, so this is how we're supposed to write it. All right, with the applications, I can't stress enough how helpful it is to draw a picture. So if we have a man pushing a lawnmower at an angle of 30 degrees to the ground, okay, we're always going to be thinking about these as little right triangles. So my angle is 30 degrees and he's exerting 30 pounds of force. That is, we're looking at this as a force vector. So it's just the magnitude. We can also look like in number 19, this is what, number 18, and then that's just basically exactly like the problem we just did. We want to know find the horizontal and vertical components. Well, we have the magnitude and we have the angle, right? So we're just going to use our formulas here that the x is the magnitude times cosine of the angle, and the vertical y is the magnitude times sine of the angle. Okay, number 19, a jet is flying in the direction of north 50 degrees east. So I draw my little thing. Here I have north, west, east, and south. So my little jet is starting off facing north, and then I turn 50 degrees towards the east. Okay, so here's my new jet. That's where I'm facing. This right in here is 50 degrees. And I am flying at a speed of 700 miles per hour. Okay, so this is going to be, my vector is going to represent speed. That is the magnitude. Okay, now that 50 isn't quite the angle. That would be here, but for the vector, we need the angle with the horizontal. So we have the magnitude. Oh, that's not degrees, that's the magnitude. Okay, and then this adds up to 90, right? Because that's a 90 degrees. So it would just be 90 minus 50. Gives me the angle here is 40. So I have my magnitude and I have my angle. And now I can figure out the north and east. All that means is just the vertical and the horizontal. Okay, so these are just like what we did in problem 16. No, 12, 14, whatever that one that was, okay. Migrating salmon. Okay, so draw the picture. This is on 20. A migrating salmon heads in the direction of north, 45 degrees east. This is 45 because I'm going from the north and turning in the direction of east. So my angle, that's 45. So my angle is also 45 because those add up to 90. And we're swimming at 3 miles per hour relative to the water. Okay, now we're swimming along at 3 miles per hour. That's just the magnitude. I'm going to make this bigger. Okay, this I'll just kind of clean this up a little bit. This was 3, okay? And our angle was 45. So here we are just swimming along as little salmon. However, then what happens is the prevailing ocean current flows due east. And it's going at 2 miles per hour. Okay, so it's going in the direction of east. So what's happening here for our salmon is we are adding the motion of the actual fish itself and also the current of the ocean. And so what we're actually looking for is what's actually happening relative to the land, the true velocity of the fish, and right? So we want to see actually where it's kind of drifting. So what we need to do is add those vectors. Okay, so V, I'm going to call this one V, the vector of the fish, and the vector of the ocean. Okay, so the true vector would be, you just add them up, the fish and the current. Okay, now the fish, we need to figure out its horizontal and vertical. So that would be the magnitude times cosine of my angle. That's the x. The y is magnitude times sine of my angle. Okay, that's the fish. Now we're also going to have the ocean, and well, this one's a little bit easier because it's just going due east. So all there is a horizontal. We're just going to, I mean, we could actually do this all out, cosine of 0, right? And then the vertical would be magnitude times sine of 0, but sine of 0 is just 0. So that, and cosine of 0 is 1. So it just ends up being 2 times 1 or 2, 2 times 0 or 0 for the vertical component. Okay, and now here, cosine of 45, that would be root 2 over 2. Sine of 45, root 2 over 2. So then we just add those up. Okay, so we'd have 2 plus 3 root 2 over 2, that's the horizontal, and 3 root 2 over 2 plus 0, or we just can just write 3 root 2 over 2, and it's asking us to put it in IJ format. Okay, well, we can do that. 2 plus, and I think it may have just rewritten it like this, which is fine. That's the horizontal, and 3 over 2 root 2 is the vertical. Okay, so you're always looking for where are the little triangles, and in this one it's a little bit complicated because we're getting the triangle of the little fish, right? He's swimming along, and then we have this of the ocean, and then but the fish itself, he's got an angle of 45 and a magnitude of 3. It's 3. This is 45. And then you're thinking, okay, what's my x? What's my y? All right, hopefully this helps. We can meet as well if you need a little bit more help.